Today's video will be about soil and the study of soil, which is known as pedology. As we go through, please make sure you are filling in your notes and that you stop the video when you need to so you can write some things down. In the United States, we don't really use the term pedology. We call it soil science. So let's talk very quickly about what soil is. Soil is made of loose, weathered rock and organic material in which plants with roots grow. Um, some of you probably call this dirt, but here in our science we're going to call it soil. Now thinking loose weathered rock, remember weathering means to break down rocks. So we're talking about small broken down pieces of rock, and also organic material, which means maybe leaves or plants, animal material, anything that was once living is going to be part of that soil. Now, the material from which soil is going to form from is known as its parent material. So just like when we refer to parent material with igneous, sedimentary, and metamorphic rock, we're talking about what is that soil made from. So what rock or what parent material is making the soil. And we're going to find today that there are many different types of parent materials that can make soil. So let's first talk about the composition of soil. Soil is the topmost part of the earth or the crust, and is composed of the following four things. Mineral material, and this makes sense because if we're breaking down rocks, remember minerals make up rocks, so of course we're going to have mineral material a part of that. Organic material, remember we're talking about pieces of plants or any kind of animal material, which is going to be found on the ground. And obviously there's going to be pockets of air within the soil, and water gets into the soil and is a part of it. So these four things are going to make up soil. Now, in order for us to make soil on Earth's surface, it's obviously going to take quite a bit of time. But as we look further into the soil, we're going to find that the minerals we see in there, specifically, we're going to find a lot of feldspar and a lot of quartz. And if you think back to what we learned in our mineral and rock unit, feldspar and quartz, they are part of the mineral group, the silicates, which means that they're made of the two elements silicon and oxygen. And if you refer back to Unit 1, silicon and oxygen make up the largest amount of the elements found in Earth's crust. So if we're talking about what is there a bunch of in the crust, it makes sense that something made of silicon and oxygen is going to be that. So here are your pictures just to refresh your memory on what feldspar and quartz look like, and just remember that's part of that silicate group. Now, as far as what your composition depends on here, there are three separate things. First thing is obviously going to be your parent material. So in order for you to have feldspar or quartz in your material, that had to have been part of your parent material, your rock. So depending upon what your parent material is, depends upon what your soil is made of. Your climate is going to be a big factor with that, specifically when we talk about organic material. So depending upon what climate you live in, are you going to have plants? Well, if you live in an arid region, you're probably not going to have a lot of plants within your soil. If you live in a nice, warm, wet climate, you're probably going to have a lot of plant material. And of course, time. We're going to learn today about immature versus mature soils. And an immature soil is obviously going to form over a very shorter amount of time. And our mature soil is going to form over longer periods of time. Now, specifically, we can talk about soil separating it into two separate types. It's really easy to remember these terms, residual and transported soils. Residual, think about the word resident. If you are a resident or if you reside somewhere, you're talking about like your house or where you actually are living. Same thing with residual soil. We're talking about that soil is forming from the bedrock beneath it. So it's forming from the stuff that's right below it, okay, of where it resides, it's right below it. So I would, when you're writing this, I would highlight the word beneath. We're talking, there's no movement here. It's forming right from the stuff beneath it. Transported, it's easy, okay? We're talking about soil that has transported from wind, water, ice, at some period of time from the rock that it formed from. So beneath it, doesn't match the soil that it is, okay? And actually, in New York State, we have a lot of transported soils here because in our last ice age, our ice or our glaciers that were moving across our state transported a lot of the soils from different locations. So here in New York State, we have a lot of transported soils. There are different types of soil texture. The way we're going to determine different texture is based on the proportion of the sand, silt, and clay in the soil. So if you look down at these pictures, if you've ever wondered why is there like a red soil versus a tan beige soil or a really dark black soil, that has to deal with the percentage of the sand, silt, and clay within that soil. Also, it has to do a little bit with the organic material, but specifically how much sand, silt, or clay is within there. So what a soil scientist is going to do is they're going to go out in the field, they're going to take a sample of soil, and they would have this sieve that has sand-sized screens, silt-sized screens, and clay-sized screens, and they'll take that soil, they'll dump it in, and each screen will stop the certain size from going through to the next. So you're going to get a certain amount of sand, silt, and clay within that one sample. With that, you will then use the soil triangle, which I'm going to show you here in a second, to figure out what specific type or texture of soil that's going to be, again, based upon how much sand, silt, or clay makes up that one soil sample. So let's take a look at this soil triangle here. We can see here is the clay, and here's your percentage of clay. Here's your silt on this side and your percentage, and your sand, here's your percentage over here. So let's say that I'm a soil scientist. I went out in the field, and using my sieve, I found that 15% of that scoop of soil I picked up was clay-sized, 70% was silt-sized, and 15% was sand-sized. I want to use this triangle to figure out what type of soil am I dealing with, or what texture of soil am I dealing with. And these are all the names within here in the triangle. So like silt loam, clay loam. These are all textures of soil. So here's how you're going to use this. If you look at the clay here, you're going to follow the arrow that is the dashed horizontal line. Okay, so 15% clay, and I would actually right now pick up my pencil and highlight as I move my mouse across here. Here's 10, here's 20%. For clay, we're talking about 15 in our example, so 15 is halfway between. So pick up your pencil here, and I would draw, remember clay goes horizontal, I would draw a straight line across this whole triangle saying that's where 15% clay is. So please do that now. You can even pause the video if you need to. Then we go to 70% silt. Silt's over here. Silt, the arrow's going down. You can see these dotted lines. So we go right to the 70, and I would highlight that 70 dotted line. Now you should see already that you're crossing your 15% clay line, okay? And that's good. You want them to cross. And then 15% sand. Sand goes up here, so it's your solid line going diagonally up this way. 15% again is in between 10 and 20. So I'm going to put my pencil right here, and I'll draw a line all the way up. And again, you should have a point now where all three lines meet of sand, silt, and clay. And wherever you're meeting, whatever box section you're meeting in, that's the kind of soil texture that you have. So in this example, you can write on your sheet of paper, we have a silt loam. So if I was that soil scientist without sampling my soils, I would know that the soil in that area is a silt loam. So what I'd like you to do is there are two more examples. Use your soil triangle here to find that out. Pause your video and then hit play again, and I'll be giving you the answers. Okay, so for your first example here, 70% clay, 20% sand, and 10% silt, you should actually end up in the clay section. Okay, so if you didn't get that right, make sure you do a double check or raise your hand and ask a teacher to help you. And for the second one, which was 50% clay, 30% sand, and 20% silt, you actually also land within the clay section. So for both of these, you should have gotten clay as the soil texture for those proportions of sand, silt, and clay. Again, if you did not get those, please make sure you are asking for help as to where you went wrong. Last thing here is soil horizons. Soil horizons are just basic layers in a soil profile. Okay, so I would highlight the word layers here. We're talking about, and we're going to learn about 5 specific layers in a soil horizon. Now, what's interesting about each horizon is that they have a very distinct color and composition that varies between different soil types. Um, so, we're going to talk about today how each horizon is going to differ based upon what color it is and what it's made of. Now, you must keep an open mind here when we talked about earlier climate and parent material, remember, and also time will affect the type of soil you have. So that's going to be shown in your soil horizon. So the first horizon that we're going to talk about is the O horizon. This is your top horizon. And keyword here, I would write down, it is organic material, okay? And here, down here are just some examples of organic material, but it's called the O horizon because we're talking about organic material. Now remember, all different types of soil in different locations around the world are not going to have an O horizon because they're not going to have a lot of organic material. So if there is organic material there, you would have an O horizon. Next horizon, which is below the O horizon, is your A horizon. This is an accumulation of humified organic material. It is dark in color because when you have a lot of organic material, it's going to be a lot of darker in color. And what you really want to remember with this horizon is it's called topsoil. So if you've ever bought topsoil at like Agway or some kind of store, you would see that it is really dark in color. So the A horizon is the topsoil. Again, not every single soil horizon has topsoil within it. And if you do farming, you obviously probably know that topsoil isn't available everywhere. So our A horizon is topsoil. Our next horizon after that is called the B horizon. Here we want to focus in that this is known as the subsoil. Okay, so again, O is the top, that's the organic material. A after that is your topsoil, and then B is known as the subsoil. Now, subsoil is lighter in color, it's denser, and it's lower in organic material. And that's because it's lower down into the ground. So less organic material means not as dark in color, and it's denser because the other layers are pushing down on it. Next is your C horizon. This contains obviously less weathered sediments than the layers above, okay? This is your parent material, okay? So this is the material that your soil is being made of, all right? So it's broken down pieces of the bedrock. So your C horizon is your parent material. And your R horizon here is known as your bedrock. So I always think of R as rock, although R stands for regolith, which is your bedrock. But if you just remember R is the rock, that will be good. Now, what's interesting, depending upon the maturity of your soil, this may be a few inches or many feet below the surface, but the bedrock is that solid rock layer in the ground or in the crust. So remember, I keep talking about how long it takes to make soil. At the initial stages of soil, it's going to be very immature, young, okay? And then we can move over to the right here to get a mature soil. So here in step one, your immature soil, this right here would represent your bedrock or your R layer. So I put a big R over that. And this is partly weathered rock, so that would be your C or your parent material, okay? So you can see here, there's no A, O, or B layer because we really don't have the capability for that here. Your immature soil, we're looking at now topsoil, which is A. Here's your parent material at C, and then you have your weathered rock of R at the bottom. And for your mature soil, you can see bedrock is really deep and there's not much of it. Now you have all your horizons, O, A, B, C, and R.